All right, make sure your phones are put away. You just follow along, right? Page 103. No conversations now, okay? Keep them for later. This part right here, we call it the ambiguous case of the sine law. And the only time you have to worry about it is if you have side-side angle. And I will show you how to recognize it without graphing. And so what we're going to have to do when it's an SSA and you have no diagram, okay, I repeat, there's no diagram when these arise, you need to determine the number of solutions that are possible. Okay? Grab your calculator and let's look at a pattern here. Can you try sine of 30? Sine of 30 degrees. What do you get? 0.5. Try sine of 150. 150 degrees. 0.5, right? Shh. Pay attention now, okay? Isn't that a problem if they're both like sine of 30 is half, sine of 150 is half? Like what's going on? Let's try another one. Sine of 20. Sine of, try another one, sine of 160. Same number. What is the pattern? Do you see the pattern? What's the pattern between the first two entries? They're both the same answer, right? But what about the angles that I typed in? They add up to 180, right? They're supplementary. You notice that? Let's try cosine. Let's do the exact same thing. Cosine of 30. It's 0.86, right? What about cosine of the supplement, which would be 150, right? We used. Is it the same? Almost, but it's a different sign. Cosine knows the difference between an acute angle and an obtuse angle. Sine law doesn't know the difference. Sine law will always give you an acute angle, no matter what. Even though you could draw it to scale, you could, don't copy this right now, but let's say, for instance, you drew a triangle to scale. You drew it to scale and you draw it out like this. And you're trying to find this angle using sine law. And let's say we know it's supposed to be 130. Let's say it's supposed to be 130. Sine law would give you the 50 here, because they're supplementary, but it would give you an angle of 50 degrees. It just doesn't know when it's obtuse and when it's acute. It just doesn't. So we'll always go acute. Cosine law doesn't have that problem, so we don't have to worry about it when it's cosine law. Okay? That is why we're having to deal with this issue right here. So, and this is going to be your homework over the weekend to add this to your study sheet. I made a flow chart for you right here. Okay? So, when you have an SSA case and the given angle is acute, you want to force your diagram to look like this. And I'm going to use two different colors here. You have the rod. I call this side the fishing rod because I like to fish. That's the best use for it here. And the fishing line, that's your string. Those are the sides that we're going to graph because, and over here, this is the angle you know. Angle given will go in this corner right here. Is this a side-side SSA? Yes, it is, because you will know a side, you will know another side, and you will know the angle across from one of the sides. Then you know it's SSA. Okay? So this is what we're going to do. We're going to call this one string, this one rod. And you're like, Mr. Dirksen, why aren't you closing this? Like, why is it up in the air? Because it literally, at first, we're going to assume that this is just like dangling up in the air, like you have a fishing rod. And we're going to see if this side is actually going to make contact with the ground. Is this triangle even possible? Okay. And so what we do here is we ask the first question right here. Is this string, I should have been ready for this. Is this string greater than or equal to the rod? If the answer is yes, like if you're able to answer yes, then it's one possible solution. Okay. And I will for now put down no need for height, because later on you're going to know what I mean by that. No need for the height in this scenario. You don't need to calculate it. You don't need it at all. So that's game over. That's just one solution. I'll tell you this. Up until this point, guys, every single case, listen to this. I made sure every single case was this case, where the string was longer than the rod, every single time. So every single one of our solutions, there was only one possible solution. Okay? However, if the answer is no, if you know that the string is shorter than the rod, okay, then you have to find the height. So how do we find the height? We go slant times the angle, correct? What is our slant in this case? Which one is touching the angle? It's the rod, right? So it's the rod times sine of the angle, the only angle that you will have. Okay? So we have to go rod times sine of the angle. So if you want to highlight rod in green, that's fine. Okay? So that will find the height in this thing. Now you have three options. Once you find the height. One option is the string is shorter than the height. You find out the height and you compare your string to the height, and its string is shorter than the height. In that case, let's draw this out. I will make this dashed and the base because we don't know what it is yet. So the string will kind of dangle down, like hang down, and it's not touching, like this is the string, and you've got the height of the triangle. Imagine the height is right here. This is the height, that is the string. And it's not touching the ground. It's just dangling. It's not closing the gap. Okay? So you have no solution in that part right here. So this is your rod. This is the string. And it's just dangling there because the string is shorter than the height. So it's just, you cannot even make a triangle. So you can say no solution, or you can say no triangle. That's what the ambiguous case of the sine law is. Like, we have to figure out, we have to narrow this down. The other case you have is where the string is exactly equal to the height. You do the math, you calculate your height, and you're like, oh, my height is 10 centimeters. My string is also 10 centimeters. They're exactly the same. In that case, you have one triangle. And what kind of a triangle would that be? If the string is exactly equal to the height, string is equal to the height. You have a right triangle. This is your rod. Okay? You have one solution. One triangle. Then you have another case. We have string shorter than height. String is equal to the height. What could be the other one? String is greater than the height. In that case, you've got two possible solutions. And hear me out here. Basically what is happening, draw this first. You have your rod. This is the height, h. And I'm going to use a different color for this string. In this case, your string is longer than the height, so it will swing up like this and make contact with the ground there. And it will also swing and make contact with the ground there. So how many triangles are you going to create? You're going to create one right there, if the string swings in, or if the string swings out, you ignore everything, you're going to create another triangle there. So there's two triangles available. Two solutions, two triangles. And these are the two. You've got the scenario where the string swings in like that, or you've got the one where the string swings out like that. Can we, if you don't mind, if you used red like me, I will just kind of go back and just say, hey, the string is here. The string in this case was just up here, was shorter. It wasn't making contact with the ground. So there's your three possible outcomes once you get to the height. Okay? In every single scenario, when you came down, let's zoom out here a little bit. I'll add some pieces here. The string, what color did I use? Did I highlight string with? I used pink. Use the same color you used for string up here. And I'm going to say string is like the main character in this whole story. You're comparing string and the rod, right? Once you've done that, you find the height, then you compare the string to the height every single time. Let's see. You compare string to the height every single time. So string and rod first, then string and height. Okay? And this is your, at the end of the day, if you want to justify, why did you end up saying that there's no solution? Because I said that the string is shorter than the rod, first of all. And then I said that the string is also shorter than the height, second of all. So that's the justification for you saying no triangles are possible. Make sure you write that down. Okay. The justification to get to this point right here, it would also be that the string was shorter than the rod. Remember, we said no, like it's not larger, so we're going down this path here. But in this case, the string is exactly equal to the height. So that's how you came up with that. That's the short justification for it. Okay? And then the last one, and I'm running out of space here, I'll be able to fit that in here. The string was also shorter than the rod. We determined that already upstream. But in this case, the string is greater than the height. folks, this is the only case where you have two solutions. When the string is shorter than the rod, but the string is longer than the height. That's the only time you have two possible solutions. And I know you're calling me crazy right now, like what is all this nonsense? For now, just hang in there. We'll go over some examples. So this is acute, right? The angle was given acute. It's a lot messier. Now let's go to the next page where it's obtuse. If it's obtuse, if it's SSA, hold on. I need to make sure you understand something. What if it is not SSA? Do we need to worry about all this nonsense? No. Only if it's SSA and I don't give you a diagram. Okay, that's the only time. If it's obtuse, you're still going to do rod and string. Okay, but this time you caught a fish. You're pulling back and you're like, yeah, right? There's your string. Please use the letters that the question gives you and just put rod and string on top of it, just so you know. Then we're good. Then you can use rod and string the whole time. But use the letters that the question gives you as well, okay? This is the angle, right? This is the angle given, and it's obtuse. It's bigger than 90. You only have two choices. If the string is greater than the rod, one solution. If the string is less than or equal to the rod, no solution. That's it. Those are your only two options when it's an obtuse triangle. And let's do some examples. Okay. Let's look at it this way. State the number of possible solutions. Okay, this is just a simple, in this case, listen up. I don't have much time. What's the first thing you're going to ask yourself? You're going to compare rod and string. String is the main character. What do we know about string and rod? Let's do this. String and rod. What do we observe? String is smaller than rod, correct? Now we compare what? String and height. You go string and height. What do we observe about this string? Look at the number, not the actual dangling side. Look at the numbers. String is shorter than height, correct? So how many triangles do we have? How many possible solutions? Flow chart. 0? Not possible, right? No solution. Boom, you're done. You don't even have to solve this guy. You know what would happen if you tried to solve this one? If I gave you this, you would get an error at some point. If you try to solve it, you'd be like, oh yeah, it's going good. Error. What? That's what would happen. Like you would not be able to solve this triangle. Next. Remember? You compare side, string and rod first. So this is my rod, this is my string. What do you observe? The string and the rod in terms of the numbers, the string is shorter than the rod. Now you compare string and height. String is shorter than the height, so no solution. Pick something better, Mr. Dirksen. This is not working. This one. Please do this. Rod, string, height. Do that. Let's compare the rod and the string first. The string is shorter, correct? I need to go to the next step. I need to compare string and height. What do we notice about them? Exactly the same. How many triangles do you have here? One. What kind of a triangle? Did I say that? I didn't say that. Oops. What kind of a triangle do we have though here if this is a 90? Right triangle. So I will just say that it's a right triangle. Got it? So this is one triangle, and it's a right triangle, by the way, specifically. Okay, this is different. This is a little different. Rod, string, height. Compare the string and the rod. What do you see? The string is greater, right? Do I need to compare the string and the height? No. When the string and the height when the string is greater than the rod, one solution, one triangle. No need for height. So if I ever make up a question for you, and it's SSA, up until now, I always made sure that my string was larger than the rod, and then we're good to go. You never have to worry about it. Okay. What about this one? Rod, string, height. Compare the string and the rod. Forget about the height at first. What do we notice? The string is shorter, correct? So you got to go down that path. You got to go down and then it's string and height. What do you notice? String is greater. How many solutions? Bingo. 0, 1, 2. What do you want, Mr. Dirksen? 2. When the string is greater than the height, this technically, you can feel free to do one of these. This technically is longer than the height, so it can do one triangle here and one triangle there. So 2 solutions. One more. What kind of a triangle is this? Obtuse, right? What are my only 2 options? The only thing is you never find the height. You just have to compare string and the rod. The string and the rod. What do you notice here? The string is greater than the rod, correct? One solution. Over here, this is the rod, this is the string. String is less than the rod. No solution. What if they're exactly the same, guys? What if the string is exactly equal to the rod? No. No solution. Because what? No. Look at this. If this had been 83 and it's exactly the same as 83, you just cannot make a triangle, right? Like this will swing in and make contact here. So I'm going to stop there. There's a little bit more that I'm going to